In this video, we are going to be learning about summation notation. So let's get into it. First of all, we need to understand what summation notation is, or commonly known as sigma notation. This is a common example. When you add the terms of a sequence together, it becomes of a series. Summation notation uses the Greek capital letter of sigma to concisely represent the sum of these numbers. So, let's write a normal expression for a summation notation. Okay, now that our summation notation formula is written out, let's start labeling them out. Right? So this I symbol, this is just the index of the summation. This mostly just tracks your position. And for beta, beta here is your lower limit. So basically where you want your sequence to start for your addition. And n is the upper limit, so that's the last number you want to add when you plug in the value. And A1 is just the explicit expression. Okay, now that we have that, the next thing we have to do is, we have to know what the formula is, right? So there are two types of sequences. There's arithmetic sequences and geometric sequences, right? So I already did a video on arithmetic sequences. If you want to learn more about arithmetic sequences, you can check out that video on my channel. But I haven't done geometric sequences. I'm probably going to do that tomorrow. But the difference is, well, there's a difference for arithmetic sequences. So 2, 4, 6, and 8, those are an arithmetic sequence because they have a common difference. But if we start at 2, and then let's say we go to 8, 32, and 128, this is a geometric. And this is arithmetic. This is because this has a common difference of 2, but this has a ratio of 4. Now that we have that out of the way, we can start writing down the formulas for finding the sum of arithmetic sequences and geometric sequences. So, for arithmetic sequences, the sum is n terms over 2 over the first term, which is a1, plus the last term, which is an. And then there's one more that is, I'm trying to remember, Sn equals, it's still n over 2 plus, no, sorry, not plus, times 2 times the first term plus a common difference, the common difference, and n minus 1. And the common, and to find the difference, so d difference that's equal from the first term, which I'm going to denote by L, minus the last term, which is going to be E over delta, so the number of units, or digits. And then for geometric, we have Sn equals a1 plus 1 minus r to the power of n over 1 minus r. And to find the common ratio, which is r, you just do L over E and then delta, so the number of digits, or numbers. So yeah, let's get started with the first question. So evaluate each expression. So for this one, we can use, let's use the first one, so this one. So it's n over 2 multiplied by a1 plus an. So as you can see, we'd start with 1. So we're plugging in 1. And then the last term is 10. And then there are a total of 10 terms. So 10 over 2 and then negative 5 minus 32 equals negative 185. And if you still don't understand what summation notation is, I'm just going to manually do a summation notation question without using the formula. Here we go. So basically, it's 3. I had to duplicate this a bunch of times. And now you plug in the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now it's -5 plus -8 plus -11 plus -14 plus -17 plus -20 plus -23 plus -26 plus -29 plus -32. And if we add all of these up, we should get -185. So that's what summation notation is.